So we're going to be looking at the second method of solving a quadratic algebraically. So we looked at taking the square root, and now we are going to look at completing the square. Now, because we've already spent a few days on completing the square, I'm hoping that this won't be as difficult. So we're going to go ahead and review of what completing the square is and how we used it to put a quadratic in vertex form. So far we've only used completing the square to really just rearrange an equation, but today we're going to be solving. So we're going to go back to writing in vertex form. So remember the first step, we said that let's just make this equal 0, and then let's go ahead and create a new C value, and we're going to move the 1 over. So if we move it over, we have to subtract it, and because we added something to the left side of the equation, we have to do the exact same thing to the right. Okay, so we're going to go ahead and create a box. And remember, we take the first term and place it in the first box. You take your middle term, which is 8x, and you divide it in half. So we get 4x and 4x. Then you come up with your edges. And so 4 times 4 is 16, so that completes the square. And you go ahead and put those in your blank spaces. So from there, we're going to go ahead and write out the factors, but we've already factored it. It's x plus 4 and x plus 4. So we're going to write that as x plus 4 squared equals, and then we have negative 1 plus 16, which is 15. And the last thing that we want to do is go ahead and move that 15 over to the other side. So we get x plus 4 squared minus 15, and then we have y equals, okay? So we just put it in vertex form by completing the square. So we're actually going to do the same process, it's just a little bit different at the end. So now we're going to solve. So remember, when we're solving quadratics, what we're really doing is we're finding the x-intercepts, or where the graph crosses the x-axis. So this one, they already moved the c value over for us. That's the 3. So we're going to go ahead and rewrite this, but remember, I'm trying to come up with a new C value. That would make this a perfect squared trinomial. So I'm going to go ahead and add in my blanks to both sides. So far, everything is the same. So the next step is to draw the box. We take x squared, we put it in the first box. You take your middle term of negative 4x and you divide it in the diagonal boxes. You come up with the edges, and then you have negative 2 times negative 2, which is 4, which is our completed square number. Okay, so far, the same exact process. And then we take our factors, which are x minus 2 squared equals, and we add 3 plus 4, which is 7. Okay, this is where it's different. So in the last problem, to put it in vertex form, we moved everything to one side. But now we are solving. So I'm trying to get this x by itself. So I have to think about what we can do. Well, think back to taking the square root. In order to get x by itself, we would actually want to square root both sides. So we end up getting x minus 2 equals plus or minus the square root of 7. So just a reminder, the reason why we're square rooting is I need to get x by itself, but right now it is being squared. So in order to undo the square, we square root it, okay? The other thing, just like the other day, you have to do plus or minus, okay? So the last step we need to do is add 2, and we get x equals plus or minus the square root of 7 plus 2. Okay, so the square root of 7 we can't really find, so we just leave it like that. And so remember, this is actually 2 answers. It's positive root 7 plus 2 and negative root 7 plus 2. So this is where the graph crosses the x-axis at those 2 points. So if we wanted to know exactly where it was, we could actually put root 7 in our calculator and see what that would look like. Okay. Next problem. So this one we have to move over that 36. So we get x squared plus 16x plus blank. When I move the 36 over to the other side, it becomes positive, and I get plus blank. Next step is to draw your box. So we put x squared in the first box. We take 16x and we divide it in half. We get 8x and 8x, and we fill out the rest of the edges. And you do 8 times 8, which is 64, and that gives you the completed square number. Okay? Then you take your factors. Well, the factors are x plus 8 squared, and you add 36 plus 64, which is 100. And remember, we're not going to move it over because we're solving for x. So in order to get x, I have to square root both sides. So I get x plus 8 equals plus or minus, that's got to be automatic now. The square root of 100 is a perfect square, so it's 10. Then I subtract 8 from both sides. So I get x equals plus or minus 10 minus 8. So just like we ran into this with taking the square root, we want to finish that because those are like terms, so we can add or subtract them together. So positive 10 minus 8 is 2, and negative 10 minus 8 is negative 18. So again, there are two answers because the parabola crosses the x-axis at 2 and negative 18. All right, last problem. So once again, this one did not move over that c value for us, so we will. So I'm going to do plus blank. I'm going to move that 2 to the other side and create a new blank. And again, the reason why it's positive 2 is in order to move it to the other side, we have to add it. Next step is our box. So we take the first term and put it in the first box. We take our middle term, 6x, and divide it in half. Then you come up with the edges, and you do 3 times 3, which is 9. And that is our completed square number. You take your factors, which are x plus 3, and there are 2 of them, and then you add 2 plus 9, which is 11. In order to solve this, I need x by itself, so I have to get rid of that squared by square rooting. So I get x plus 3 equals automatically plus or minus, and then the square root of 11, and then I can subtract 3. So I get x equals plus or minus the square root of 11 minus 3. And that would be it because I can't take the square root of 11 and get a nice number. So we just leave it like that. So this section, again, was solving by completing the square. And that is it.